this lab, you will determine the density of various metals. From that information, you will try to determine the unit cell dimensions of the metals. The way the atoms pack to one another is essentially the unit cell. I liken it to bricks in a brick house. And from that unit cell, you can get the unit cell edge length and the volume of the unit cell. So in turn, the volume that the unit cell occupies when these metals arrange to form their metallic array. So before we go into determining the density of these metal solids, let's just show you the metals that you will work with. First is copper. It's pretty heavy, so you can, when you see it in the lab and weigh it out, you can just feel that it's dense just by feel. Then there's nickel. Now, my opinion is it's kind of light. Then there's steel. Okay, that's iron. Okay, this is pretty heavy. Okay, this is just my qualitative observation. Here is lead. Okay, it's kind of intermediary. And then finally we have zinc. So you can see just by holding it up, some of these are a little bit more dense than others. So that implies the way these atoms pack together in their unit cell and their unit cell dimensions are going to be different. So the first thing you want to do is take a blank balance with a weigh boat and take your metal. Now you'll want to weigh out an appreciable amount of the metal that you are determining the density of. Remember, the formula for density is mass over volume, mass of the substance divided by the volume the substance is in. So mass over volume. But we want an appreciable mass so that we can get an appreciable volume that gets displaced when we determine the density. So here's our copper. Now, how much do you want to weigh out? Probably 15 to 20 grams, maybe 10 grams. But I'll just go and have a happy medium and say 15. So it's at 0.00 pairs. I'll go with about 16.690 grams of copper. So I'll get my volume. Let's just put water here. So 16.690 grams. And I have about 29.0 mils of water. Okay, remember, record this volume to 1 decimal point. And now I'm going to measure the volume displacement. Okay, so 16.690, 29 mils. So you want to do this very slowly. Otherwise, you may run the risk of cracking the glass. So just very gently. So from 29.90, my new volume is 32.0 mils. My previous volume was 29.0 mils. So you can use your mass over volume equation. The volume displaced is going to be about 32 mils minus the 29.0 mils that I weighed out, and my mass is the mass that I weighed out. You want to get that mass to be around the 10 to 20 grams range, maybe 15 to 20 grams. It won't hurt whatsoever even if you weigh out 25 grams or 26 grams. Okay, so the only thing that we ask of you is you want to add it slowly when you displace the water. You don't want splashing, and you also don't want, especially for some of these more dense metals, such as steel, you don't want to run the risk of the glass cracking. So in this lab, you will use volume displacement to determine the density of copper, nickel, iron, lead, and zinc. Do the same procedure as we've done before. Weigh out a certain amount of metal, a good amount, and slowly put that in a graduated cylinder that already has some volume. Measure the volume displacement, and that will be your volume. Density is equal to mass over volume. Fill out that table in your results section of your lab. Now, that's not all. There's going to be a lot of data analysis. Remember, at the very beginning, we talked about unit cells, and each of these metals are going to pack in an arrangement. So the arrangement of atoms is called a unit cell. So that arrangement has been determined beforehand. So for example, copper has a unit cell packing arrangement of face-centered cubic. So does nickel and lead. Iron has body-centered cubic. That's how the atoms are arranged in the unit cell, the brick in the brick house. And zinc is hexagonal closet packing. Go to your lab manual and look at the appropriate equations for each of these unit cell packing arrangements and determine the unit cell edge length, determine the volume that is occupied by the atoms in the unit cell. And one final note, you will want to use units of angstroms. Angstroms. This is called an angstrom. Generally, we use angstrom to measure bond lengths, such as a carbon-carbon bond or a carbon-oxygen bond. In this case, since we're dealing with atoms and the radius or the length of a unit cell in the way these pack towards one another, we can use the unit of angstrom. And the unit of angstrom is 1 angstrom is equal to 1 times 10 to the minus 10 meters. So that will be your lab, your second lab for chemistry 2. So after you measure out the volume displacement of water, there's a note I want to tell you about waste. Don't throw this away. We will recycle this. So dump out the water and put this back in the appropriate container. We will let the copper dry and we will use it for other experiments and the other labs. So don't throw away the metals. Put it into its proper receptacle when you're done.